any room for the class to crash or not?
Depends on which section. Are you coming from a different section of 90?
No, I actually did the 90 class.
No. My 90 class has 3 different sections, and it depends on which lab time. Because we don't just meet in this room, we meet in other rooms.
I know. I was just there, and I see that you're from over here.
Oh, you were in the lab?
No, I wasn't in the lab. That's what I'm saying.
Oh, I see. Let me talk to you after class.
Okay, so I'll wait in the back.
All right, guys. There's something I noticed when I was walking around helping people out with their homework, and I know this is a fact, but I do want to kind of take a minute because I noticed it is a definite issue with a lot of people. Fractions are not our friends for some reason. Don't feel bad because don't feel bad, but my 180 students, my calculus students sometimes have trouble with fractions. This does not mean it's okay, right? But let me show you a few things that will help you out, especially when you're trying to add, subtract fractions with really gross denominators, right? First off, I want you to realize something. When you add and subtract, the requirements are more strict. So for example, help me out. What is y plus y plus y? Careful. 3y. Because historically we just decided, instead of writing all those damn y's, let me just put the number 3 to indicate there are 3 of them adding. And then the poor little dude that wanted to multiply, he had to put the 3 somewhere else to indicate multiplication. I like it. So it's all just shorthand, really, that we got to get used to. Now, what is y plus y squared plus y cubed? Oh, shit. No. No, you can't do anything with that. There are no like terms. Do I have any other y's? No. Do I have any of the y squared terms? No. Do I have any of the y cubed terms? No. So to add and subtract anything, guys, to add and subtract anything, they have to be like terms. To multiply stuff, not as restrictive. Now this is so that's the answer there. You can't do anything with that. But what is y times y squared times y cubed? I can do something with that. Careful. Y to the 6. I see a y times 2 more y's times 3 more y's. So that's a total of 6 y's multiplied.
So you're adding.
Yeah, because it's y times a couple of y's times 3 more y's, and of course that is 6 y's multiplying. So notice, exponents, now go with me. Exponents are based on what operation? Multiplication. Therefore, if I am multiplying, I should be able to handle the exponents easy as long as the bases are the same. Exponents based on multiplication, so will it play well with addition? No. Does that make sense? I mean, that's hopefully, they're based on multiplication, so they're going to play well with multiplication. They're not based on addition. They're not going to play well with addition. How's that so far? And you're all like, you started talking about fractions and then you did this shit. Well, here's the connection. Yeah, like, please take your meds today. So here's the thing. If I have 3/7 plus 2/7, those are like terms. I have 3 somethings plus 2 somethings equals 5 somethings. In this case, those somethings are sevenths. The answer is not 5/14. I don't have any frickin' 14ths. How do you get 5 of them? Do you guys see the idea? Don't just try to memorize the process. See why it makes sense. This really is just a like terms. This is just like 3x plus 2x. 3/7 plus 2/7 is 5/7, just like 3x plus 2x is 5x. So, if I am if I'm adding 2 fractions that don't have like denominators, then they are not like terms yet, right? So this one's an easy one. I'm building up to the uglier ones. This one should be an easy one. I have 5/14. I better make this some number of 14ths because I can do that. I'm always thinking about what number can both of these become. Well, 7 can become 14, and that's already 14, right? So, of course, what is this guy missing? Another way to look at this is 14 is 7 times 2. So you can see, what is this guy missing that this guy has? A 2. So you give them a 2. To make it legal, you do the same thing to the top and bottom. So now I get, what do I get here? 6 14ths plus 5 14ths is 11 14ths. I love it. Now, hopefully whoever I stole it from doesn't move. Let's do some that have a slightly more disgusting denominators, right? So let's say 5 over 21 plus, what you got, Jeff? Sure. 6 over 35. Slightly more disgusting denominators. So what I do is, I start with, the whole idea is, I don't have to give them what they both already have. What do I mean by that? What's the biggest number that 21 and 35 share? 7. So break them both down as 7 times something, and you can see then what they're each missing. It makes LCD shit so easy. I don't know why more people don't teach it like this. So 21 is 7 times 3. 35 is 7 times 5. So now please, what is he missing that this guy's got? A 5. I love it. Come here, purple. So it'll be 5 times. What is he missing that he's got? A 3. So you see how the bottoms both become whatever 7 times 5 times 3 is. Yeah, I like it. What is 7 times 5 times 3? 105. So this will be 25 over 105 plus 18 over 105. So 25 stuff plus 18 things is 43 over 105. Does that help out at all? I have handouts too. Trust me, if you have any trouble with specific stuff from Chapter 1 review stuff, I have handouts. And don't feel bad, it's going to say Math 88 at the top, but it might be a while since you took it, or your last teacher didn't really go over it much, or whatever. Or your last teacher never even showed you this procedure. So don't feel bad that it's from some lower class. Who gives a shit? It's just an idea that you need to know. Right? So I have handouts if you want to come by and get them. I really don't feel like making 120 copies if I don't need 120 copies. So you can just ask me or email me and I can shoot it to you. Right? Or I can post it on the website if I think about it, if somebody reminds me. How's that? Any other lingering questions about fractions that you want to ask now while we're talking about fractions? I know there are. You guys are like, no. I don't want people to know. But if you trust me about this, if you have a question, at least 27 other people in this room have the same question. Right? And you would be their hero if you ask. Yes? So yeah, I did that weird derivation, but I wanted you to see why it's true. Are you talking about like if I had, 4 11ths divided by 55? Oh, that's really evil, Jeff. Let's not make it that evil. 4 11ths divided by 16 over 55.
Are you supposed to cross multiply or multiply across? Wait.
So the only time that you cross multiply, you ready? Do you see how I slowed down and I said it twice and now I'm going to say it a third time? The only time you cross multiply is when you have an equation with one fraction on each side. That is where cross multiplication comes from. Do you guys understand what's happening? That's the only time. So is that what I have happening here? No. So then don't do it. I like it. And what? Let me see if do I want to show you cross multiplication real quick, just because it came up. It's a shortcut. Cross multiplication is a shortcut. What sucks about this problem? Frickin' fractions, right? Just to cut to the chase. So how do I kill this 3? How do I make this not a fraction anymore? Multiply both sides by 3. Is that cool? So on this side, it cancels. So what does it look like the 3 did? It looks like the 3 came up there. Did it really? No. I multiplied both sides by 3 so it would cancel on one side. But what, I'm developing a shortcut. Well, that 3 just comes up there. Now how do I kill the x? Times multiply both sides by x. So now the x's cancel. But what's it look like the x did? It looks like it came up there. So then I end up with 21 equals 15x. Get out of 15. You're good, Jeff. 21 equals 5x. There you go. And then how do I solve for x? Divide by 5. So real quick, the way this would look, if you apply the shortcut directly, is you would say 3 times 7 is 21. X times 5 is 5x. See, that's cross multiplication. That's a shortcut, though. And when people learn it, it's not really emphasized that it's a shortcut, and then you start thinking, whenever I see fractions, there must be cross multiplication. No. Only in this case. Because it's a shortcut of how to solve that equation. Here, there's sort of a way you can apply the idea, but then you have to be really clever and really careful, and let's not do all that kind of weird shit. How do I do this problem?
Turn it into a multiplication.
Yeah, times, and instead of doing 4 times 55,
4 times 16.
4 times
careful.
4 into 16.
Yes, you can cross-reduce now, right? 4 goes into 4 once, 4 goes into 16 4 times. 11 goes into 55, so then you get 5 over 4. Bam. And I showed you the other day, maybe it was yesterday, I showed you yesterday why we multiply by the reciprocal. And it was kind of gross. It was a way you would never do it, but it explains why it works, right? I like it. Anything else about fractions while we sort of have a pass the candle kind of thing? Yes, I have a problem with fractions. No? No? Okay, all right. This was your moment, and it's gone. Okay. So I wanted to talk about that because I saw that before, and then I saw it this morning. So please don't feel like you're alone. My God. Right? But please don't feel like that means you don't have to worry about it. Okay, so what I want to do today is get right up to the point of word problems. We're going to get into word problems next week. Oh, yeah.
Why, Jeff?
Hmm?
Said why, Jeff?
Oh, because I feel like torturing you. So, word problems, I understand they get a bad rap, but they're the most important damn things. More generally, they are modeling situations in life. Unfortunately, the word problems you get, I am concerned about the people. I can't remember, did I put this little thing on the homework sheet? There's a little Peanuts thing where Sally's like, the only place where you could buy 60 cantaloupes and nobody worries about you is freaking math, right? There's a problem. Jerry goes and buys 60 cantaloupes. You're like, wait a minute, Jerry's got a problem. Or he's got a cantaloupe party, and that's kind of weird. You guys, so you have a guy, so a word problem in algebra would be, this guy forgot how much money he put into these 2 bank accounts. Like, what kind of, I wish I had that problem. What? Was it 17,000 or 18,000 I put in this account? What the hell? I know all too well that I have very little in every account. So a lot of the problems are very contrived, and they're really just to get you used to how to model a situation, but we don't know enough math to model full, blown-out, real-world situations. So they have to be a little bit contrived. And then that makes you guys kind of lose faith, right? It's like, why would this person not know how long they were riding their bicycle? Lewis went 60 miles down there, and he was going, how long was he? What the hell's wrong with this guy? Who is this person? Well, it's just getting used to the setup. Anyway, so that's in our future. So yesterday, we ended up here with the solving of equations. And like I said, solving equations is bread and butter. And your Math 88 should have really emphasized solving equations. If you took Math 88, well, hopefully wherever you came from, they emphasized equations. Now here, we have the evil situation. Somebody freaking stuck fractions into our equation. It's like, wow. Well, what's really nice about number 5? Yeah, all the denominators are the same. Now, what do I wish I could do if I saw fractions that were in a problem? I wish I could kill them, right? That would feel so good. So what am I allowed to do with an equation that I'm not allowed to do in some other situation? I can do something to both sides. I can multiply both sides by. I can multiply both sides of this by square root of 11. I can multiply by whatever the shit I want to except 0. But what would be really smart to multiply both sides of that by? Because of all the divisions by 4. It would cancel all that stuff out. That one thing would make no fractions left. Sounds good. So if you multiply everything by 4, these 4's cancel. So what am I left with there? Negative x. These 4's cancel. I'm left with 5. These 4's cancel. I'm left with a 3. Oh my God. That looks nice. You with me? All right. So that problem was a little nice because it started off with all the denominators were the same. Now how do I finish this problem out? Careful. Subtract 5. To get that variable thing by itself. What's 3 minus 5? Negative 2. And I hope you guys can realize whenever you have negative x equals something, x must equal the opposite. If negative x is negative 2, x must be 2. How are we doing so far? Now, what's a little bit worse about number 6? A couple things, actually. Different denominators, there's a lot more shit running around in number 6, right? It's a little bit longer. I'm going to show you a method that I prefer because it's going to help us when we get to the point where we don't just have numbers down here, we have variable expressions down here. Chef, what the okay. So I have a method I prefer. There's 2 ways to do this. I'm going to show you the way that I think is going to help you later. And it also kind of applies to non-equations. I have to get an LCD in the first place anyway when I'm just trying to combine fractions. So what would the LCD be? It's not too bad here, right? 6. So who needs what? Whoa, that's really American. This is already 6. This guy needs 2. This guy needs 3. This guy needs 3. This guy needs 2. I like it. So let's see what we get. Negative 5 sixths r plus 4 sixths equals 15 sixths plus 3 sixths r, right? Is that cool so far? Plus 32 sixths. Okay, let me stop there. So is there any number in there, the bottom of which is not the same as the other ones? No, we made all the bottoms 6. Which means now it's just the same as the problem we did a second ago. So now I'm going to multiply both sides by, that's incredible, right? So if I multiply both sides by 6, and you see how it would distribute to both?
Yeah.
Please, dear God, don't write negative 30. There's no point, because what happens with all the 6s? They die, right? 6 is dead, dead. 6 is dead, dead, dead. So then what am I? Are you guys with me on this? Yeah. It's because it's an equation. That's the one time you're allowed to kill your fractions. Let me actually be more general. As long as you have 2 sides of something that you can balance each other out with, you're allowed to kill your fractions. How are we doing? Yeah, you make them all the same bottoms, and then you multiply by that bottom, and all the fractions are gone. Thank the gods. The trade-off is you made the tops a little bigger, but who cares, man? Oh,
I was just stretching.
okay. I care. Oh, I'm sorry. So what do you get here? What's left over? What's left alive in here? Negative 5r. Plus 4. 15. 3r. 32. I like it. So the fundamental idea of do the opposite, you can still see it here. There are things being divided by stuff. So what am I going to do? Multiply by something. I'm going to do the opposite, right? And now it should be easy. Take a minute and just try to finish that out. Should. My safe place to stand over. So let me see here. What can you do on this side? Yeah, good. So you 3r plus 47. And now you get to this point in a lot of equations, letters, numbers, you just pick a way to move them so they're on opposite sides. Who did what with the r's? Say again?
Add 5r.
You can either add 5r or subtract 3r. It doesn't matter. It's not better really, but it's a little bit better in a way to add the 5r because then you don't let there be a negative that might screw you up later. But if you subtract the 3r, you're not wrong. Just got to be careful with the negative. So I would add 5r, add 5r, 4 equals
8R
8r
plus 47.
plus 47. And now since I chose to move the letters this way, I got to move the numbers the other way. I like it. Minus 47. Minus 47. Yep. Negative 43. Let me write this up here. And then finally, what do you do?
Divide by 8.
I'm running into the side there. Yeah, the r's not by itself. I get rid of that stupid 8. So I get r equals this beautiful negative 43 over 8. So the answer doesn't have to be beautiful. Right? Don't think you're wrong just because you don't get a whole number.
I got 43 over 2, so I don't know.
Oh!
Where
I think right here, the 3r and the 5r. What'd you do at that stage?
the 3r, I subtracted it by.
So negative 5 minus 3.
Yeah, okay, yeah.
Okay.
I didn't put the negative on.
I got you. Well, it'll be negative 8.
Yeah.
Okay. I like it. So it should end up with an 8 on the bottom. Everybody cool so far? Yes, sir. Yeah. Sorry. All right. All right, you ready? Improper fraction. Yeah. Improper fraction is top heavy. Yeah. All right, guys, so hopefully it makes sense that not every equation is going to have an answer, and actually some equations will have an infinite number of answers. So how the hell would that be true? Well, what if I said, x plus 1 equals x plus 1? So what number do I add 1 to? And it's the same thing as when I add 1 to that number. Well, that's all the frickin' numbers, right? So these are kind of weird little equations that that's an easy one to tell from the beginning. Well, that's going to be any number I want it to be. There's no specific number that makes it work. So most equations, there's only a specific number that makes it kind of balance out and work. But these equations are kind of special, poor little equations. And what's going to happen when you solve them is the variable is going to go away. Because what did I just say? Does it matter what I make x in that case? So if I had the problem x plus 1 equals x plus 1, get over here, and you try to start to solve it using the steps, what would you do to solve this? Okay, minus 1. That gets a little bit freaky. Are your x's together yet? No, so I would minus x. And I love when people just circle that. I'm like, wow, 0 equals 0. Good job. But what this is trying to tell you, now stay with me. When I solve a normal problem like x plus 1 equals 2, and I get x equals 1, the way to interpret it is when this statement is true, then the original statement is true, right? When x is 1, then x plus 1 is 2. Okay, that's cool. So when this is true, then the original statement is true. Well, when the hell is this not true? Every other Thursday. No. 0 is always frickin' 0, so that's telling you all real numbers make this work. There's no condition. The x went away. It doesn't matter what x is. It's always true. So what if I instead get, well, let's try a problem out here. Try to do number 1. Understanding that something weird's going to happen. Yes?
Do we have to solve it down to 0 equals 0, or can we just...
No, 5 equals 5,
Yeah.
7 equals 7. That would
like
mean...
x minus 5 equals x minus 5. Like
Yeah, even there.
Okay.
Yeah. Get far enough so I can tell that,
Yeah.
you could tell that that's the answer, yeah. Just that number 1 there, try that. Be really careful with that negative. Oh, shit.
Must take a while to upload long sessions. Huh?
Actually, nowhere near as long as you might think. It's pretty quick.
Is that at least the duration of the video? How long it takes to...
Roughly, yeah. Are you guys, I think a few of you guys are watching the videos. That's cool. Don't forget you got the videos of the lectures up on the YouTubes, on the internets.
Is that plural?
Internet is a series of tubes. Alright guys, so the thing you got to be careful about, what's got to happen right here?
Change the inside of the sign.
Distribute the negative 1. I like it. There's like an understood negative 1 out there. So this is still 2x. Minus x minus 5.
Equals x minus
2x minus x is
X.
x. So I get x minus 5 equals x minus 5. So like somebody said, right there you could say all real numbers. It doesn't matter. Don't say infinite number solutions, because the answer to a question isn't how many answers are there. The answer to a question is the answers. So all real numbers. So if you keep going though, if I get my x's together, I would subtract x, and here's where I love you guys to death. Here's where some of you guys, for some reason, you hated when x came into math. But now some of you try to save the poor x. Oh, x, don't die. X is going to frickin' die, right? X minus x is 0. No x is left. The part of your brain goes, I don't know what to do when there's no x. Dead. Negative 5 equals negative 5. Don't circle that.
add 5.
The answer, well, you don't have to kill. When is this not true? This is always true, so the answer is all real numbers. Well, this is 2x minus x, which is just a single x. Yeah, I like it. How would you check this? Pick a couple numbers. Any number you want to. Put 3 in there, it's going to work. Put 7 in there, it's going to work. Put 0 in there, it's going to work. That's how you check all real numbers. You just start picking a bunch of numbers, and they're all going to work. Don't check every real number. That would take an infinite amount of time. Let me see where there's going to be a nifty one. Yes, trial number 3. Let's see what you think about number 3. of course, in the back row there, if you want to just be looking at your Facebook, you can do that. I don't know why you want to do that here. It's probably better to do this. But that's just me, I guess. I gotta be careful about that -4 a little bit. Bringing it through. So what do you get here?
12x minus 6. Negative 12 plus 12x.
All right, you guys with it? Since that was a -4, it's going to change the signs when you bring it in. If you do that wrong, you're going to get, obviously, the wrong answer. Get your x's together. How do you get your x's together? You would subtract 12x. Gone, gone. So you end up with -6 equals. And then I get people that either circle that, which is interesting, or they add 12 and then they start and then they just keep doing stuff to both sides, praying something's going to happen. So if 5 equals 5 is always true, and so that means all real numbers work. -6 equals -12. When is that true? Never. So there is no solution. That was a bogus equation somebody wrote. It's the same thing as if I said, when is x plus 1 equal to x plus 2? Well, that's bullshit, Jeff. You can't add 1 to something and have it be the same thing as if I added 2 to that thing. No. So that would be no solution. So there are bogus equations. Of course there are. So this would be no solution. If you just circle this or just stop and don't put no solution, you will lose points because you haven't told me the answer yet. In this case, it's the fact that there is no answer. All right, how we feeling there? I love it. When is that true? Never. So the answer is no solution. So see, you just added 6 to both sides. There's no way I could do something to both sides of that and make it come out to be equal. Because they're going to both change by the same amount, whatever I do. So it doesn't really matter how much you do, you're going to end up with a not true statement. I love it. Okay, cool. Now, the next level of solving equations, you're going to love this, is when you have an equation that has no numbers in it. Right? Have you guys seen that before? Jeff, why? So let me build us up to this. So how do I solve this? 2x plus 3. Let me write this one. Equals 5. How do I solve that? Good. So now watch this. Let me put something right next to it. Try to do this in your notes too. Ax plus b equals d, just to be different. Now let me see if you guys understand what I'm about to say. Those are the same. If a was 2, b was 3, and d was 5, those are the same. Are you with me? Now, a and b and d could be different numbers, but let me say it like this. Those involve the same steps to solve for x. Because no matter, I don't care if this would have been a 4, would you have done something different in the first place? No, whatever that number is, I'm going to subtract it, right? So if I subtract 3 first here, what am I going to do first here? Subtract b. I'm always finding where my variable is, getting that term by itself first. Why is ax not by itself? The stupid b. So let me kill that stupid b. So if b was 3, that would be exactly the same, right? So then I end up with 2x equals 2. Over here, in a way, somebody pointed this out once. A student said, well, this is actually easier because I don't have to actually do anything. Because what is d minus b? D minus b, right? So here I get ax, these cancel, equals d minus b. Don't write db, because that implies multiplication, which is not happening anywhere.
Isn't it
It's just, huh?
Isn't it technically an A, because 2 is the A? Yeah.
Oh,
Talk about?
if they had those values, then you could say it's equivalent to the value of A.
Then you could divide
This
it by
one is just a general one. I don't know what A, B, and D are. I like it. I heard you over there. Don't confuse everybody, please. Now, what's the last step here? Divide by the number with the x. So what's the last step over here? Divide by the number with the x. It happens to be a number I don't know. I don't care. It's a times x, so I can divide by a. So I get x equals d minus b over a. Now watch. What did we say? If a was 2, right? If a was 2, b was 3, and if d was 5, these would have been the same equation, right? So what do I get when I plug those into here? That's the answer for this. I'm just going to go one step further. Then if this was the case, this would be, can you guys see that? Yeah. 5 minus 3 over 2, right? D minus b over a, which is 2 over 2, which is 1, which is the same answer we got over there, of course. Now, this is good, because what if I had a whole bunch of different values for D, B, and A? If I just replaced it here, I would have to solve, every damn time solve. If I can do this, I only have to solve once. And then I can just plug the stuff in, get the answer. Plug the stuff in, get the answer. Much, much better. Right? And I know you're not all going to become computer scientists. I know you're all going to become math major, whatever. But still, that ability to manipulate just variables helps with so many different things. Right? It makes more efficient computer programs, so you're not wasting time redoing some shit over and over and over again, so forth. Okay, maybe. So. Oh, shit, where am I? Oh, good. What about, let's try number 2 here. This is page 9. What is that the formula for, by the way?
Circumference of a circle.
Circumference of a circle, I love it. So try to do what that's asking you for. Solve that for R. It's a one-step problem. So you can say to yourself, why is R not by itself? Because of what? Stupid 2 pi. What's the 2 pi doing to the R? So let me do the opposite to it so it goes the hell away. Divide by the shit that I don't want. Right? I want R by itself. I don't want 2 pi. Let me divide by 2 pi because it's multiplying by my poor little R dude. So divide by 2 pi. Divide by 2 pi. I get R equals C over 2 pi.
So if we see pi, we're just going to put pi side. We're not going to do like 3.14.
Oh my god, dude. Yeah. Because the reason we gave it... Real quick about pi. I was going to do this anyway, so... do you guys know what that pi symbol represents? It doesn't represent 3.14, by the way. That's an approximation. It represents 3.1415, blah, 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 blah. So, by the way, March 14th is a big day for math geeks because 3.14... Right, so we really geeked the shit out when it was March 14th, 2015 because it's 3.1415. So that was like, we called it Super Pi Day. Trust me. There's so much that math teachers do that you're like, I don't need to hear that kind of stuff. But we had freaking pi. It was young as shit, right? But does anybody know where pi... This is always a funny question. Where pi came from? Julian. No. Where does pi come from? Pi, the Egyptians had a number for pi. It was 22 divided by 7, which is not that far off. And then all these different, the Greeks had an approximation for pi. What they noticed is, no matter how small or big a circle is, when I measure around the outside and divide it by the diameter, it always came out to be the same number. So of course, in the ancient times, they'd be like, well, that's divine. That's holy shit. That's like, you cut the earth in half and it's still the same freaking number when you divide. So if you take the distance around, which is the circumference, and you divide by the diameter, you get the same number every time. So we gave it a special symbol, of course, we just called it pi. Because it never ended, right? It's a freaky number. And of course, why does that actually come out to be the same formula? Because if I multiply the d up, I get c equals pi d. And what's the diameter? How is it related to the radius? You guys remember? Yeah, the radius is half. So it would be 2 pi r, because twice the radius is diameter. That's the formula for circumference. So to be honest, the formula for circumference comes from the definition of pi. Shit. And some of you guys are like, I didn't need to know that, but too bad. You know that? Okay. What is number 3 the formula for?
Area for a triangle.
Area of a triangle, yeah. Because if I have a parallelogram or something, its area is height times base, and a triangle would be half of that. Hey, it's amazing. So the area formula for a triangle is half height times base. Half height base. Good, sorry. I had a little... Remember that song? No? Good. Probably better. So how the hell... What would be a really good first step in any equation solving that has a fraction?
Multiply by the denominator?
Yeah. So if I multiply both sides by 2, that immediately makes it look so much freaking better. You guys see that? So if you have an equation with fractions in it, like we saw earlier today, you're completely allowed to kill the fractions. As long as you do it correctly. It's got to involve multiplying by the denominator, or denominators, if there's several. And then, how do I solve for b? Why is b not by itself? Yeah? Yeah, b is not by itself because that stupid h. Let me divide by h because it's multiplying. Bam! So then I get b equals 2a over h. Bam! I love it. Must be getting close. I see a lot of heads doing this. Who knows what number 4 is the formula for?
Trapezoid.
Trapezoid, I love it. So it's the area of a trapezoid. Do you see how it looks like 2 triangles if you distributed that? Half height times A, half height times B. Because any trapezoid, you can break it up into 2 triangles. Nifty. I'm not going to take you through that whole derivation. Take a minute and try to do number 4, solve for H. Let's see what you guys do. And then we'll probably head out after that, just to get you guys excited. Yay! So obviously that problem we just did, there's a giant hint of what to do first to make it look so much better. Kill it. That's right. So what's the first step?
Multiply by 2.
Yeah, multiply by 2. Bam! You get 2a equals h times a plus b. Now to be honest, there's actually a couple different ways to do this, but what did you guys do next?
Divide by a plus b.
Yeah. Oh, they were solving for h. If you're solving for a or b, there would be a couple different. But here, this always freaks people out. This is a single number. If a is 2 and b is 3, that's the number 5. So it's h times some number. I don't want this stupid thing, so I divide by it. Bam! So I get h equals 2a over a plus b. I like it. All right. I think that's plenty. So next week we are going to get into word problems. Next week also is the week of quizzes in the labs. Yay. Yeah, we're glad we got it. We have a quiz at the beginning.